Rescue Education, we help you to learn faster, easier, and better. I'm Dr. Christine Brzezowski, and I'm going to help you learn organic chemistry. Today we'll talk about the nomenclature of alkenes and alkynes. This video exactly follows my help book. My book also contains extra test your knowledge problems and complete solutions. Here are the pages to find everything. First, we're going to cover alkene nomenclature, the IUPAC nomenclature. With alkenes, you find the longest chain containing the double bond, and it must contain the double bond, and that's the parent. Sometimes it is not the longest chain overall. Then you change the ANE ending of the alkane with the same amount of carbons to ENE. The double bond gets the lowest possible number. We don't worry about any of the alkyl substituents because alkenes, double bonds, have higher priority than any alkyl groups. When you have a cycloalkene, the double bond is always at position 1 and 2. If you have multiple double bonds, which is a fairly common event, if you have 2, you change the ANE ending of the corresponding alkane, cycloalkane to adiene. A-D-I-E-N-E, and if there's 3, ane changes to a triene. Pause and try these problems, then we'll solve them together. The first one, you see the alkene is sort of in the middle of the chain, but it's not in the longest chain. The longest chain is from left to right, but because there's an alkene, it has higher priority. It must be included in the parent chain. So the parent chain is actually this one. And we have here the substituent, the isobutyl group, okay? And the corresponding alkane with 6 carbons is hexane, so we change the A and E ending to a hexene. And we will have to deal with numbering it, giving it a number, so leave a little space. And then on this parent chain, we have the isobutyl group. Now, I'm not going to number in both directions here. I think you can see that we would prefer to have the alkene at the 1 position. So this is a 1-hexene, and the isopropyl is at the 2 position. So this is 2-isobutyl 1-hexene. Make sure that you put this 1 here. Many people lose points on exams because they assume that if the double bond's at position 1, you don't need to number it. You must number it. The second molecule here, the longest chain goes from left to right. And so this has 8 carbons, so this is going to be an octene. Again, leave a little space for a number, and we have 2 methyl groups. So this is a dimethyl octene. The question is, what is the numbering going to be? So the only thing we need to take into account is giving the double bond the lowest possible number because it is higher priority than the methyl groups. So in fact, the correct way to number this is as follows. So we put the double bond at the 3 position. This is a 3-octene, and the 2 methyls occur at the 7 position. So this is a 7,7 dimethyl 3-octene. Cyclic alkenes, we change the name cyclohexane to cyclohexene. So this is a cyclohexene. We also have 2 substituents on here. We have an ethyl and a methyl. Methyl is connected to the cyclohexene name, and then the ethyl comes first because E beats M. What is the numbering, though? Because the double bond is the most important functional group, it has the highest priority, we must have 1 and 2 position go through the double bond. So that's one way to number. Then you can number in the opposite direction. When we number around the outside, we have 3, 5 for the two substituents. When we number in the other direction, we have 4, 6. So 3 beats 4 at the first number, so this is a 3, 5 numbering. 3-methyl, 5-ethyl. So this is a 5-ethyl 3-methyl cyclohexene. It's very common to have two double bonds. And when you do that, you pay attention to having the double bonds have the lowest possible number. So this is a cyclohexadiene. And you can see the two methyl substituents. So this is a dimethyl cyclohexadiene. Again, we spend most of our time just trying to figure out the numbering scheme. So we will number through the double bonds and give them the lowest possible number in this direction, but you can also go in the opposite direction. And no matter which direction you go, you're going to get a 1, 3 cyclohexadiene. But the question is then, where are the methyls, the two methyls? We can choose 5 or 6, and of course we'd like the lowest number. So this is a 5, 5 dimethyl 1,3 cyclohexadiene. We need to talk about two simple compounds that have common names that are used exclusively. So ethylene is the 2-carbon alkene, and propylene is the 3-carbon alkene. And again, everybody uses those names. There are two double bond containing substituents that occur frequently. If you take ethylene, remove one of the hydrogens, you get the vinyl group. If you take propylene and you remove one of the hydrogens on the methyl, you get the allyl group. So they're used more in common nomenclature, but they're used very often. So here we have this molecule is called vinyl bromide, vinyl cyclohexane, and likewise the allyl group is used in more of the common nomenclature, allyl alcohol and allyl cyclobutane. You notice that we haven't covered the stereochemistry, the three-dimensional nature of the double bond. The cis, trans, and EZ designations of double bonds are covered later in the stereochemistry unit. Alkyne nomenclature is exactly analogous to alkene nomenclature. You pick the longest chain containing the triple bond as the parent, even if it isn't the longest chain overall. Then you change the ANE ending of the corresponding alkane to YNE. The triple bond gets the lowest possible number over alkyl groups because it is of higher priority. There are compounds that have both double and triple bonds, and these are called enines. If you have an enine, you change the ANE of the alkane to enine. Then you number in both directions, and you try to give it the lowest possible number at the first point of difference. If the two schemes are exactly the same, turns out the alkene has slightly higher priority than an alkyne, and it wins in the numbering. The one common name you will definitely need to know is acetylene, the simplest of the alkynes. Pause and try these problems, then we'll solve them together. In the first problem, we need to find the longest chain containing the alkyne, and of course that's the horizontal chain. And we're not going to bother numbering in both directions. We'll just go ahead and number in the correct direction. So this chain is 9 carbons long. So this is the nonane is the alkane parent chain. And we will change the ending to non-ine and leave a little space for where exactly is that number. This is also a dimethyl, so we have 2 methyls here. dimethyl nonine, and the triple bond is at carbon 3. It has priority, so that's really the only thing we have to worry about for direction of numbering. And the 2 methyls are at the 8 position. So that's 8,8 dimethyl 3 nonine. Now the next 2 problems are related. So as we number, you can see that this is a chain of 6 carbons. So hexane is the parent alkane name, and this is an hexene, and then it's an ine, but we need to leave a little space to indicate where the triple bond is. So when we number from right to left, this is a 1, 4, E9. When we number from right to left, this is a 2, 5. And at the first point of difference, 1 beats 2. So the correct numbering scheme is a 1, ine, 4, ene. So 4 hexene, 1 ine. In the second problem, this is also a hexene ine. We see that no matter which direction that we number, this is going to be a 1, 5. So when you have a 1, 5, the double bond gets slightly higher to priority. So this will be a 1 hex, ene, 5 ine. The double bond wins to get position 1. I want to insert at this point something that's sort of related to alkenes and alkynes, and those are groups that are derived from aromatic compounds, because these occur frequently in first semester, and these are called phenyl and benzyl groups. If you take benzene and remove one of the hydrogens, formally, you get the phenyl group. If you take toluene and affect methylbenzene, and you remove one of the hydrogens off of the CH3, you get the benzyl group. A place where you might find phenyl being used as a substituent is, for instance, if you have a long alkane chain and you have a benzene group attached, then the phenyl becomes a substituent if that chain is longer than 6 carbons long. Pause and try these problems, then we'll solve them together. Okay, the first problem illustrates one of the cases when you would use phenyl. So we have a long 8-carbon chain, and the benzene ring that's attached to it has only 6 carbons. So the alkane chain becomes the parent, and we have the phenyl substituent on it. So this is a phenyl octane. And even though the phenyl is at position 1, people often leave that 1 off, and that you shouldn't, because there's other phenyl octanes that are not the same compound. So make sure you always put in the number 1 phenyl octane. The second example shows you that if your alkane chain has fewer carbons than the benzene, then the alkane chain becomes the substituent. So this is simply called ethyl benzene. No need to put a 1. The ethyl is assumed to be at position 1. And finally, this is more common nomenclature, but this is the only way that this compound is ever named, and that is as the bromide parent. So this is called a benzyl bromide. If you found this video useful, you'll love my new organic chemistry help book. It takes the essential topics of first semester organic chemistry, puts them into discrete units with concise and crystal clear explanations and many sample problems. But the best thing of all is it has test your knowledge problems. So extra problems that help solidify your knowledge, and all the solutions are included at the back of the book. If you're interested in my book, go to my website, rescueedu.com.